Hi guys, here's your lesson for Friday, April 17th. You should be on slide 6 of Class Kick. The question for today is, how can we generate electricity? You're going to answer the 3 questions after watching this lesson. And you need to view the video generator dissection on FOSS-Web. All the directions are on top of the page so that you can add more detail to question number 3. First, we're going to do some review from the last lesson. I showed you what a motor looks like and the components of a motor. These are the wires. We have the plastic cap with the brushes. Then we have that metal casing inside, which has a metal shaft that has a commutator on it, which acts as the switch that turns the electromagnets on and off. And there are 3 electromagnets in this motor. However, all 3 do not go at one time because there's only 2 contact points in the cap where the brushes are. So that means that all 3 are not on at the same time. We also talked a little bit about how the energy transfers in a motor when it's in a circuit. We know that the battery is the chemical or potential energy, because it's stored energy, goes through the wires, becomes electrical energy, and then moves the shaft. Remember, this was turning, which I can show you again, and that creates kinetic energy, which is energy of motion. And I made a chart to show that, and I'll show you right here. So here it is again. The battery has the stored energy that is going through, which is the electrical energy through the wires, and the shaft moving is the kinetic energy. Remember, it's potential energy, which is stored energy, turns into electrical energy, and then the shaft moving creates the kinetic energy. I want you to think about this question. Do you think it's possible to transfer kinetic energy into electrical energy? To explore kinetic energy, I have a tool called a hand crank generator. Now, I want you to look and see what kind of energy is this. Well, we know it's kinetic energy because I'm moving. But what is happening? The gear's moving. Don't see the light bulb turning on yet. If I crank it faster, maybe the light bulb will turn on. Oh yeah. What evidence do we have of kinetic energy? What other energy could be in this besides kinetic energy? The light bulb's turning on. It's also heating up. So that proves that there's also electrical energy. So what energy transfers were occurring that made this all happen? Well, first we have kinetic energy. Then something happens in here that creates electrical energy. And then we produce light energy, or the heat. To try and show you what's inside the clear casing. Here is the page that I put at the bottom of slide 6 to help you answer some of the questions. It shows you the inside of a hand-powered generator. As you can see, there are contact points. There's 2. There's a coil. So a hand crank generator is different than a regular generator because you're actually doing it yourself. So what we're doing is we're turning a shaft which goes into the metal casing, and then it goes into the circuit, that's through the wires, and into the light bulb. So there's also electromagnets in this as well. It's very similar to a motor in that the shaft hits the metal casing, turns on the electromagnets. By turning the shaft, we're creating electricity. When the shaft turns, it moves coils of wire in a magnetic field that induces an electric current in the wires, like an electromagnet in reverse. That current travels through the circuit and lights the bulb. This system is called a generator because it generates electricity. But it does not create energy out of nothing and doesn't have stored energy like a battery, so there's no potential energy. Generators transfer energy from one place to another, in this case from kinetic energy of the turning shaft to the electrical energy that lights the bulb. Generators used during power outages at campsites and for motor homes are often powered not by a hand crank, but by engines producing kinetic energy that are in turn fueled by gasoline, which is a form of potential energy. So hand crank generators do not use potential energy, but actual generators do when they have a fuel source, such as gasoline. So here's what is happening in a hand crank generator. We turn the crank, which is the kinetic energy, the energy of motion. The wire coil turns into a magnetic field. The electric current generated in wire is the electrical energy. And then when the shaft rotates, it's kinetic energy. Last but not least, I'll compare generators to motors. In a battery/motor system, we know that the chemical/potential energy turns into electrical energy and then produces the kinetic energy. However, in a generator, in a hand crank generator, we see only kinetic energy to electrical energy. There's no chemical/potential energy unless it's an actual generator, not a hand crank one. Another thing that is similar between the two, well, those were more like, there's a couple similarities, the kinetic energy and the electrical energy, but the one difference was that the battery provides the potential chemical. But another similarity between the generator and the motor is that they both have a shaft with electromagnets in them. A generator and a motor are typically the same thing, pretty much. They're considered the same component depending on how the energy is transferred. So this is the end of my lesson for today. Make sure you watch the video Generator Dissection on FOSS-Web. The login information is at the top of slide 6. If you have any other questions, please contact me. Bye.